As we pivot from the physical substrate of metamaterials, we confront the most profound mathematical challenge in human history, the Riemann Hypothesis. To understand the mechanical necessity of this topic in a hardware roadmap, we must look at the foundation of modern cryptography. The security of almost all digital communication relies on the distribution of prime numbers. The Riemann hypothesis proposes a specific pattern to that distribution. If a quantum computer can solve this problem, or more accurately, if we can develop quantum algorithms that utilize the underlying patterns of the Riemann Zeta Function, we will have achieved the ultimate key to the world's data. Classical computers have checked trillions of cases, but a proof remains elusive. A quantum computer, however, operates on the same probabilistic and wave-like principles that seem to govern the zeros of the zeta function. There is a deep theoretical link between the energy levels of complex quantum systems and the distribution of these zeros. By building hardware that mirrors these mathematical structures, we aren't just doing math, we are observing the solution through the behavior of the quantum system itself. This observation is the mechanical equivalent of a proof. The mechanical implication of this is the end of classical encryption. If the Riemann hypothesis is mastered via quantum computation, standard RSA and ECC encryption will not just be slow to break, they will be fundamentally transparent. For a firm invested in data sovereignty and specialized tech, this is the quantum zero day. It necessitates a total migration to post-quantum and hypothesis-resilient security frameworks. You're preparing for a world where the very concept of a secret is redefined by mathematical certainty. We are moving toward geometric security, where data is protected by the fundamental topology of numbers. This is a shift in the very paradigm of digital safety. Furthermore, the mastery of the Riemann hypothesis provides a roadmap for infinite optimization. The zeta function is deeply tied to the way energy and information are distributed in complex systems. By applying these mathematical insights to our hardware design, we can create resonance-optimized processors that operate with the highest possible efficiency allowed by the laws of physics. This is the perfect tuning of the digital world. As you manage complex DevOps pipelines and hardware R&D, utilizing these mathematical patterns allows for a level of system stability and performance that mimics the natural harmony of the universe. Deeply and honestly, this mathematical alignment is the ultimate goal of all technical research. We are not just calculating, we are aligning our systems with the architecture of reality. To expand further, the software implications are just as vast as the hardware ones. We are developing new compilers that can translate Riemann-level logic into executable machine code. This allows for algorithms that can predict system failures before they happen, based on the harmonic patterns of the processing load. This predictive harmony is the future of server management and DevOps. It ensures total uptime in even the most demanding environments. We must also consider the role of quantum annealing in this process. By cooling our systems to near absolute zero, we allow the quantum states to settle into the patterns described by the hypothesis. This is the physical manifestation of the math. We are moving toward a world of deterministic complexity, where the chaos of large-scale systems is tamed by the underlying elegance of prime distribution. This understanding allows us to build networks that are not just robust but biologically efficient, routing data with the same organic precision as a neural network. The Riemann Zeta function is defined through the sum of integers, but its properties are revealed through the primes. This duality mirrors the relationship between hardware and software. The hardware is the continuous medium, the complex plane, while the software is the discrete execution, the primes. When these two are in sync, we achieve system resonance. This is the state where the computational cost of a task drops to its theoretical minimum. For an R&D laboratory developing autonomous systems, this efficiency is the difference between a mission's success and failure. We are building the mathematical infrastructure for a new era of intelligence. This is not just about proving a theorem, it is about harvesting the power of that theorem to drive our technological evolution. The critical line of the hypothesis is the boundary between the known and the unknown, and we are stepping across it. Every zero we identify on that line is a new coordinate in our map of the digital frontier. In conclusion, the Riemann hypothesis is not just a math problem, it is the source code of the numerical universe. By pursuing its solution through quantum hardware, we are ensuring that our technical infrastructure is aligned with the deepest truths of reality. We are moving from estimation to exactness, providing the ultimate mathematical foundation for everything that follows. The primes are the building blocks of information, and we are learning how to stack them. This is the final frontier of logic, and once breached, it will change the way we view information forever. The mathematical certainty we seek is within our reach, and the hardware we are building today is the vessel that will take us there. There is no turning back from this level of understanding, and the strategic advantage it provides is absolute. We are coding the universe with the language of the primes. The implications for cryptography are particularly stark. The Riemann hypothesis is tied to the error term in the prime number theorem. Understanding this error allows for the creation of more secure prime generation algorithms, but it also reveals the vulnerabilities in the current ones. We are currently developing Riemann-resistant protocols that do not rely on the difficulty of factorization, but on the intrinsic geometry of the complex plane. This is a higher order of security, one that remains robust even in the face of infinite classical computing power. As we transition our clients to these new frameworks, we are ensuring that their data remains sovereign and their communications remain private. Our commitment to this research is driven by the realization that mathematics is the ultimate arbiter of truth in the digital age. By aligning our hardware roadmap with the most fundamental theorems of mathematics, we are building a legacy of technical excellence that will endure for generations. The roadmap for 2026 and beyond is paved with the zeros of the Zeta Function. We are the architects of this new numerical reality, designing the systems that will safely navigate the complexities of the prime-driven world. Every quantum gate we design is a tribute to the elegance of number theory and the power of human logic.